So essentially, I work at the University of Chicago. I'm originally from Charlottesville, Virginia, so I'm always happy to come back to the East Coast. I lead a weekly R Spatial workshop there, so I teach researchers how to use spatial data. And this talk is essentially cribbed from that. Every time I teach that, every week I teach that, researchers come up to me and they're like, yeah, like you showed me how to make these cool maps and like do these analyses in R. How do I get the spatial data? Like, what is spatial data? Like, what's a shapefile? Like, can you help me with that? And so I decided to sort of take a step back, and instead of telling you about my cool spatial autocorrelation and regressions and things that I love, I'm going to take a step back and think about the step before that. So how do you get spatial data? What is spatial data? How many people here have worked with spatial data? Okay, so a lot of people have. So maybe this is maybe too elementary for you. How many people feel like they have a good grasp of what spatial data is? Yeah, so hopefully today's talk will clarify a little bit of that, talk a bit through some of the tips that I find helpful, maybe walk through a few tools that I use as well. This is good. I just get like extra minutes to talk at you. Great, awesome. So spatial data. A little bit about me. I wanted to talk a bit about the communities I'm a part of. The only reason I'm on this stage is because of the amazingness of our community. And if you want to be on this stage, you should be on it because you're part of the art community and you're valued and you're awesome. So let's see. About me, this is me teaching my workshop at the Center for Spatial Data Science at the University of Chicago. I half do research, half like help people with their own research. Last year I was just helping people with their own research, and that drove me a little bit crazy. So I was like, put me on a project. You can see up here, I'm teaching people how to make a choropleth map. I'm helping people debug their spatial installations, and I believe back here I'm like presenting a little bit of my own research. I'm also part of the Our Ladies community. I run the Our Ladies Chicago group. You should, if you're in the area, you should go to the Our Ladies DC group, which is run by Kelly and Gwen back in the corner. Or if you're in Charlottesville or other parts, I think Sam is outside, so she runs the Our Ladies Charlottesville group. I have found this community to be super welcoming and just really helping me along in my learning journey. We do hackathons together. We have talks. We talk about cool things we've learned in R together. For me, it's been a really good way to force myself to learn things by getting up in front of a stage and practicing talking about Shiny or maps or the tidyverse. Okay. Carpentries instructor, I recently joined this community. So the Carpentries is a community that encourages researchers to become better at their computational ability. The idea being that when you're in grad school, people just sort of expect you to know R all of a sudden. Like, I don't know when that happened. Like, they're like, yeah, you know Git, you know Shell, you know R, you know Python, et cetera. Go do your analysis. And it's like, where do people learn that? Part of the Carpentries community is teaching people how to do that. So if you're interested, I have carpentry stickers as well. I don't know if there are any carpentries instructors in here. Is anyone a carpentries instructor? Okay, there are like a few in here, maybe one. You can also, by the way, if you are at an academic or nonprofit or I think probably even governmental institution, you can request carpentries instructors to come do workshops for you at your institution. And we're volunteers. So anyway. Sorry. And there are a few other things. When I'm not thinking about spatial data or communities in open source, I play Ultimate Frisbee, big fan of that. I don't know if anyone here plays Ultimate Frisbee. And I love biking as well, so this is me biking around, I think in Mexico City. So, okay, previously, I gave a talk last year. I naively thought this would be the last time I would ever give a spatial talk at DCR, so I called it bit.ly DC Spatial. But we're back for more. bit.ly DC Spatial 2019. So I guess I'll just keep naming it the year, or someone else can take on the spatial talk for next year, and I'll give you permission to use the 2020 one. Last year's talk was a bit more about a specific use case. I pulled some crime data from the DC Open Data Portal. You can go to that link and check it out if you're interested. This time, I'm going to talk a bit more about one step before that. How do I get started with spatial analysis in R? So this is, where do I get that data? What tools do I use? Like, what can I even do? What does that mean? I'm going to break this down into 3 parts. First, where do I start? Second, what tools do I use? And 3, the exciting part where there are lots of maps and things, what can I do? So first, where do I start? This meme right here, you could replace this with a really ugly spreadsheet and a beautiful ggplot2 visualization. And you get the same idea, right? So most people, when they think of spatial data, they think of beautiful maps, amazing visualizations, cool stuff, what Alex showed you yesterday. I'm here to tell you that unfortunately there's a step before that. So this is right here, it's sort of what a GeoJSON looks like in real life. And then you see this and you're like, oh no, how do I get from that to that map that I want to see? I actually don't believe the whole thing here. I believe everyone deserves a look at a beautiful map. Everyone deserves to have awesome visualizations. But I want to sort of talk about that data stuff before. So this is going to be really boring for like maybe 5 minutes, but I'm going to try to make it interesting. There are two main types of spatial data. There's vector data and raster data. So how are these two things different? Vector data is points, lines, and polygons, and raster data are grid, pixels, and cells. So I'm going to mainly be talking about vector data because in the social sciences, I have a background in economics. This is what we mainly work with. We look at, where are firms located? Where are county borders? What are road networks looking like? Grids, pixels, and cells, you can imagine satellite imagery. So when satellites fly around, they take pictures of like how land is used, like oceanography. Folks in sort of environmental sciences use a ton of that. Not really spatial data. Controversial. Addresses, zip codes, counties. Why isn't this really spatial data? Well, it sort of is. It's spatial data to humans, right? So we know addresses. We can use zip codes to figure out, where is my favorite restaurant down the block? We can use this to navigate through the world. However, if you're going to be working with computers, and if you're going to be using R to do spatial data, you need a way for addresses, zip codes, counties to become interpreted by computers. And that's going to be taking the form of, coordinates, points, lines, polygons, and all of that. So this is sort of a hard thing to grasp, and a lot of people I work with have trouble grasping this, which is why I get a lot of Excel spreadsheets that say, hey, here's a list of emergency departments, like make a map, right? Like analyze like where things are. So right here, this is me reading in with Read Excel, this Excel spreadsheet I got, assigning it to this variable called ERs. By the way, if you didn't know, if you put parentheses around variable assignment, you'll get a print as well. So that's pretty cool. So this is what the data looks like. I'm like, yes, emergency departments. And I'm like, no, it's not really spatial data, right? So I have hospital names. I have the location, which is the city and the state in Illinois. And I have this like mysterious region, whatever that means. Now, in order to make this into spatial data that I can work with, I can't just have the city and state and region. If I had outlines of the regions, maybe I could like start doing a join, doing things like that. Let's say I just want to plot where these hospitals are in Illinois. So not good. We're going to do a thing called geocoding. And this is the step that like a lot of people don't realize that they have to do. What is geocoding? By the way, thank you to Georgetown University for hosting us. This is an awesome auditorium, so shout out. I used you all in this example. What you do is essentially take text input, say an address or something, and what you're going to do is throw it into a function, say geocode OSM, which means use the OpenStreetMap API to do a geocode. And then I'm going to throw in this address and then get coordinates out. The coordinates are really what I need. So you can see that I get x, y, and then the third thing right there, the B box, is like the square around that feature. So imagine it's sort of like the edge of like the outline of your map, right? You may also notice that we have x, y. This is hard for people. It's not latitude and longitude, it's longitude and latitude. Every time I think about this, I have to be like, latitude and longitude. Nope, the other way. Like longitude. So I've done this before and made maps that are like completely wrong. So I see some nods in the audiences. You may have encountered this. Okay, so geocoded it. I have an appendix slide talking about some ways that you could geocode. I have access to the University of Chicago geocoder, which is awesome if you're at an institution. This is probably the best way to geocode things in bulk. Otherwise, if you're sort of doing it for fun, you can use, there's a slide in the appendix sort of talking about how to do this. Let's say I go ahead and geocode. There's a CSV here, and this is much better. So you can see here, when I geocode it, I get an ID column sort of just to do that on. I get the address, and I split it up using separate into city and state, and I get a latitude or a longitude and a latitude. I always get it wrong. I also get a match score, which tells me how close is this likely to actually be where it is. talk to your GIS librarian, or talk to your GIS expert, or talk to someone who has a license of ArcGIS, and they can do this for you. Or you can do it yourself. So, all right, cool. Dots on a map, yay. So this is essentially how you go from that Excel spreadsheet that someone just tossed at you and like, make a map. And you are going to go ahead and do this process and convert it to this. There are a few intermediate steps here before you get into a map, but I'm here to talk to you about like the part that no one understands about spatial data. Spatial data formats are confusing. So the most common spatial data formats are the following. Shapefiles, GeoJSONs, GeoPackages, CSVs, TIFFs, there's so many more out there. There wasn't really a standard before, and like everyone sort of came up with their own spatial data format. These are the 5 that I use the most often. You'll see shapefiles a lot. Shapefiles are sort of the file format that was pioneered by Esri, which is the company that makes ArcGIS, and it's sort of become prevalent. Unfortunately for you, shapefiles are actually 4 files because for some reason it was like impossible to like store. Geospatial data can be really large because you have all these massive polygons and things, and so they decided to store it into 4 files. So you need all 4 in your directory in order for it to work. That's why I sort of prefer GeoJSON. This is more common if you're doing web mapping, if you're working with devs and they want to make a map. GeoJSONs are sort of what they're probably going to use to like create those maps and things online in apps. I've started moving to GeoPackages. They're awesome. They're one thing. They don't cut off your variable names. Shapefiles cut your variable names off at 7 characters, which is very annoying when you write them. And CSVs, as you saw before, I usually get CSVs with like latitude and longitude on them. So I just use them as geospatial data. And finally, TIFFs when you're dealing with raster data. Many more. There's so many spatial data things. These are all read by GDAL, which is the Geographic Data Abstraction Library. Okay, so you can look at these all day. All right, to use these file types in R, I have started moving to a library called SF because it reads all of these file types in without me having to worry about it. I do library SF, and then I use stread, ers.shapefile. Alternatively, if you prefer tidy data, aka you don't want your files read in with strings as factors, I like read SF, so this is another way to sort of do that. Creates a tidy SF data frame. So it looks a little bit similar to your normal Tibble. There's a little summary at the top with some spatial information. The most important thing is it is a normal Tibble, but it has this geometry column right here. So each geometry, aka each shape, is stored as a series of like coordinates and things, and it's in that last column called geometry. This makes it so that you can use the tidyverse and use those tools with spatial things like this, and which is nice because for me, it means going from normal analysis where I'm just creating, working with data tables that are not spatial, I can use the same tools when I'm working with my spatial workflow. And that is like huge because before this, working with spatial data can be a hassle. It can be like you have to change it into like this list column and then doing a lot of things that way. So this is what I prefer for that. Okay, this may be the most important slide on here, and when I wrote it, I was like, why didn't I share this with anyone before? How do you Google search for spatial data? How do you find spatial data? These are the keywords that I would use to find spatial data. So, park district boundaries, food vendor shapefile, administrative district polygons, road network geometries, abandoned car GIS files. Remember, addresses, zip codes, and regions are not spatial data, and they can't be interpreted by computers. So what you're going to look for are these like geo things, right? Polygons, boundaries, lines. And so, for example, if I search DC boundary, shapefile, geospatial, shapefile, GeoJSON, just all of it, just to be careful, I get this nice DC boundary. Remembering how to Google, what to Google is how you get anything done. So. If you want to take a photo of this, I think this is possibly, I want to just share it out because I think it's the most important slide I've ever made in my life. So, great, okay. So then you get the first 3 sort of options are from the Open Data DC portal. I highly recommend, sometimes just knowing what to search is like the door that unlocks everything, right? So, okay. So what tool should I use? And I'm definitely going to run out of time. So my toolkit is Geoda, QGIS, ArcGIS, PostGIS, Carto, and R. Given that this is an R conference, we're going to talk about the last one. But like most of us, I'm not necessarily a single use, like a single, for my geospatial analysis, I don't just use one thing. There are many R packages out there for spatial data. Does anyone know what this is? Anyone want to guess what this is? Has anyone gone to this page or like know what this is at all? Okay. This is what is known as the CRAN task view. So if you go to like the actual CRAN website, which is where you get your R packages from, there are essentially like groups of packages just listed by topic. And in this, there's a spatial one. And when you go to the spatial task view, this is what that looks like. And you go all the way down, you're like, okay, cool, all these packages. Okay, there are a lot of packages. Okay, cool. I'm going down. Let me see what packages there are. And then you get to this list. Nice. So I'm here to tell you that there are a lot of packages for everything in R. And you may not want to sort through this. So I'm going to talk to you a bit about what my workflow looks like. This is what I mainly use right now. Disclaimer, I am sort of on the, I have the time because I work at a university to sort of think through what tools I want to use and sort of what I can choose, right? Like if you have workflows that use other things, it's okay. So this is sort of what I sort of see as the cutting edge of spatial right now. Similar R packages to these. I like my tidyverse and stuff, and I like working with it with spatial data. And the reason that it's similar, that each of these are similar, are the first one, I would say SF allows you to ingest spatial data, clean it, and manipulate it in a tidy way. The second, I would say tmap. I do use ggplot too for some of my maps, but tmap, I'll show you later, has a really cool functionality where I can go between interactive and static maps. SPDEP is, because I work in spatial econometrics and things like that, that's my modeling package. You can think of it sort of like the GlimNet. You don't use it every day. It's not that, sometimes you need it. And then SP, it's like data table. Non-tidy, yet useful in certain specialized cases. And a lot of old packages sort of depend on SP, so the analogy is not quite there, but we'll go with it. Okay, what can I do? Here's the exciting part. I wanted to talk a little bit about the most recent, I think it's actually the Tidy Tuesday 2 things ago. They had some data about the squirrel census in New York City. So the data set was essentially, they sent out these volunteers to go count squirrels in Central Park. And then they recorded where they saw each of them. And I was like, yes, finally a spatial data set for Tidy Tuesday. So I was really excited about that, and I decided to do some analysis. So I actually cheated a little bit. I pulled some New York Park boundaries areas. So I think they figured out a way to classify different parts of the park depending on something. And then I pulled it into tmap. One nice thing about tmap is I went ahead and did a population count of squirrels by area in the park. You can see that there's one area that's a little bit darker. I'm like, why are there so many squirrels in that area? Are there so many vendors? And so what happened was I decided to change the mode and go ahead and do an interactive view. And so I could zoom in and out of that, right? So I ran one line of code, tmap mode view, and then I ran the same code again. Let's see it again. So I'm running my code. I'm creating a static map. I get this count by area. And then I change the mode, right? So I'm changing the mode. I run the same code again, and I get this interactive map. And so it can switch between static mapping and interactive interactive exploration like that. That for me is super valuable because I want to know the context in which I'm creating this spatial data. So then I actually took a look, and I think that red part right there, it's known as the Ramble, which I don't know if there are people here. I guess it's a woodsy part of the area. I thought maybe there were just a lot of hot dog vendors, and then I was like, what if I could pull the hot dog vendors and stuff? But they don't have. I don't know if they have data on that. So anyway. So this is one nice thing that you can now do in R, right? So you're running one line of code, and then you're running the same visualization code again. By the way, tmap, the idea, the syntax is similar to ggplot. It's just pluses, and you're adding layers on top. So that's pretty cool. So I'm alternating between interactive exploration and static mapping. Check out MapView also for a GIS-like experience. So if you are familiar with GIS and GIS tools and you sort of want to replicate that in R, MapView is awesome. It allows you to hover on things and sort of pop up ID tables. Also, Rayshader for 3D visualization and graphics. I had the fortune of being the last spatial talk, so I was like, I'll just mention some of these packages that you could use. Okay. Last thing I want to sort of reemphasize, think beyond dots on a map. So this book, How to Live with Maps. I think they're really useful as sort of a visualization, understanding basic things. For me and for my center, that's sort of like the first level, right? Exploratory spatial data analysis, you're creating these visualizations. What else can you do beyond that? Why does where matter? Why does where something happens matter? Because for example, does the house price in this area of your city, does it affect house prices around it? Does the location of pharmacies for I don't know, for certain populations, is it clustered? Are there certain places where there are gaps? And so this is important because Tolber's first law of geography says everything is relating to everything else, but near things are more related than distant things. And so when you start thinking in this way, when you start being a spatial thinker, you're going to consider, what sort of why are things close to each other? Why are they more similar? Is that a symptom of, is that spatial autocorrelation? Does that mean that there are patterns in the data? So this is using Geoda and our unit to detect spatial patterns. So I think this is Milwaukee right now, or it was Milwaukee a few years ago. We essentially had the real map on the right, which is the percentage of African American, I think, by capita, and then we just used, we just sort of randomly scattered the values across the map. When you look at a histogram of this data, they look exactly the same, right? So what we've done is taken the attributes across areas, and we just distributed those attributes across any area. So when you look at the histograms, you're the percent African American is similar. But when you look at things like Moran's eye scatter plots, you'll see that you can detect spatial patterns, and that's really, really important. So something else that you can do is look at local spatial autocorrelation. So our points, our values in an area, are they related to each other? Our values, are they more likely to be related to each other, or are they likely to be distinct from each other? Is there some relationship there? And finally, you may have done clustering, normal clustering, spatially constrained clustering. What happens if you decide to limit your clusters only to things that are next to each other? Does that matter? Does that change the output of what you have? And so with that, I wanted to mention that we have a pre-alpha release of RGeoda right up now. So a lot of this interesting spatial analysis you can do in R, and there's certain functionalities missing. If you want to test this out, I think there's still a lot of work to be done, but you can sort of see what types of functionalities are in there. And I've definitely gone over time, so if you want to stay in touch, I will be, I'm always on Twitter, and I will be TAing the Modern Geospatial Analysis tutorial at RStudioConf, and leading the geospatial track at USAR, so please submit tutorials there, and there's some of my contacts. So thank you so much.